Ever built an AI tool that needed to know who's calling it, what browser they're using, or where they're connecting from, without making users pass that information manually? You'll see how to access raw HTTP request data directly inside your FastMCP tools, extracting user agents, IP addresses, and request paths with just a few lines of code. No middleware or parameter changes required. From FastMCP, import FastMCP. From FastMCP server dependencies, import get HTTP request. From Starlette, requests import request. MCP equals FastMCP. Name equals HTTP request demo. At MCP, tool. Async def user agent info, dict. Return information about the user agent. Hash get the HTTP request. Request equals get HTTP request. Hash access request data. User agent equals request. Headers get. User agent unknown. Client IP equals request client host if request client else unknown. Return. User agent. Client IP. Path, request URL path. This demonstrates the runtime dependency injection pattern combined with context-aware tooling. The code shows how to access request-specific data like HTTP headers and client metadata without hard-coding dependencies, using FastMCP's dependency system to retrieve the current request context dynamically. What makes this distinctive is the complete separation between tool implementation and transport layer details. The pattern works by providing a standardized way to access ambient context through dependency functions. Instead of requiring explicit parameter passing through every function call, the framework maintains request-scoped context that can be retrieved anywhere in the execution flow. This creates a clean inversion of control where tools declare what they need via type hints or dependency calls, rather than how to get it. This approach solves the common problem of request data propagation through nested function calls and middleware. It's particularly valuable in RPC systems where tools may be called from various transports, HTTP, CLI, etc., but need consistent access to request metadata. The trade-off is slightly less explicit data flow, but the benefit is dramatically reduced boilerplate when building transport-agnostic services. Let's break it down. From FastMCP, import FastMCP. From FastMCP server dependencies, import get HTTP request. From Starlette, requests import request. Imports the core components for AI-callable HTTP tools. FastMCP creates the tool framework, get HTTP request provides access to the current HTTP request, and request from Starlette handles the request object structure. This setup enables extracting client metadata like user agent and IP address. MCP equals FastMCP. Name equals HTTP request demo. Initializes the FastMCP instance, the central orchestrator for AI callable tools. The name parameter identifies this toolset in logs and the AI interface, enabling clear separation between different tool collections. This is the entry point for defining all tools in your application. At MCP, tool. Async def user agent info, dict. Return information about the user agent. Hash get the HTTP request. Request equals get HTTP request. The at MCP tool decorator exposes this async function as an AI callable tool, with the docstring and type hints defining its schema. The get HTTP request dependency injection retrieves the current HTTP request context, enabling access to headers, client info, and URL data without manual request handling. This pattern keeps tools stateless while providing full request context when needed. Hash access request data. User agent equals request. Headers get. User agent unknown. Client IP equals request client host if request client else unknown. This extracts two key pieces of request metadata: the user agent string from headers and the client IP from the connection. The fallback, unknown, values handle missing data gracefully, preventing null reference errors in downstream processing. This is the standard pattern for safely accessing request attributes in Starlette/FastAPI applications. Return. User agent. This returns the user agent string from the HTTP headers, identifying the client's browser or application. Critical for analytics, security checks, and device-specific optimizations. HTTP request context pattern. FastMCPs get HTTP request. Dependency provides direct access to the underlying Starlette request object, enabling tools to inspect headers, client IPs, and paths without middleware complexity. The request context is only available during active HTTP requests, so calling these functions outside a request scope raises errors. This pattern bridges low-level HTTP details with AI-callable tools while maintaining clean separation of concerns.
The request that reveals itself was never hidden.